Let's prove the following. So we will begin by first computing vector A crossed with the unit vector I cap, take its magnitude squared. So this is the same as we take the vector A, cross it with I cap, and take the dot product with itself. That means the vector A cross with I cap. Now this is the scalar product of four vectors, and we are going to use the identity. When we have vector A cross B dotted with C cross D, this can be expressed as a 2 by 2 determinant. So this will give us vector A dotted with vector A. Then we have vector A dotted to I cap. We have vector I dotted to A vector and vector I cap dotted with I cap. All we have to do is follow the particular sequence, and this 2 by 2 determinant can be easily written. Now, A vector dot A vector, that is simply A squared, or the magnitude A squared. Then we have A vector dotted with I cap. I cap dot A vector, this is the same as A vector dotted with I cap. And I cap dot I cap, so that's always 1. When you expand this 2 by 2 determinant, we have A squared minus A vector dotted with I cap squared. So let this be number 1. Now we'll find the second term. So that is A vector crossed with J cap and its magnitude squared. So if we use the same identity, then we should get A squared minus A vector dotted with J cap squared. So this will be 2. And similarly, we can also find out A vector crossed with the unit vector K, the magnitude squared. This will be equals to A squared minus A vector dotted with K cap squared. So let this be number 3. What we'll do, we will add 1, 2, and 3. So we will have, so this will be equals to, so we have A squared, A squared, A squared. So there are 3 A squared terms. So we have 3A squared. We'll take negative common. A vector dotted with I cap. So this gives us the x component of vector A. So let's call it AX. So we have AX squared plus A vector dotted with J cap gives us the y component of vector A, and similarly A vector dotted with K cap gives us the z component of vector A. So this will be equals to 3A squared minus, so this is nothing but we take the vector A, its modulus squared. This is the same thing. So that means we have 3A squared minus A squared, which is 2A squared, and this is the right hand side.